All right, so on to example one. Let's get into actually graphing and identifying the characteristics here of the sine and cosine graph. So what we're going to do is look into identifying the period, the phase shift, the vertical shift, the range, and the reflections of each of these functions. And then I'm just going to sketch a graph. I'm not going to be perfect with my sketches. However, if you do have to kind of be detailed with you, I'll kind of talk about that as we're kind of graphing it. And then also I provided all the graphs here in Desmos, so therefore you can just kind of see exactly what the graph is going to look like. You can just pick whatever graph that you did and kind of go ahead and check your answer. So I'm not going to do that for these, or I'm not going to go and check my answer back with these just because it's going to take too much time. I will just kind of sketch a rough graph. And again, the sketch I'm going to be going off of is going to be the initial period. So the first thing that we're going to want to make sure that we remember here is these initial periods from sine and cosine. So here's the initial period for sine, here's the initial period from cosine. So when I'm applying transformations, I'm just going to apply transformations to the initial period, even though these graphs continue in both directions, hence when you looked at the graph on Desmos. But I'm just going to do a rough sketch of the initial period based on the transformations. All right, so let's go and look at this. Let's go and identify all of our information. So again, remember when we're looking at these, we're going to have a y equals a times sine of b times x minus c plus d, right? So that's basically the sine function with all the transformations where a, b, c, and d are going to affect the graph. But if we don't have a value for there, then we can just assume it's going to be 1 unless it's c or d, where we'd assume it'd be 0, because then that wouldn't, if it was 1, it would actually affect the graph. So you can see A and B are going to be multiplying. That's why we want that to be 1. And C and D are adding and subtracting. That's why we'd want that to be 0. So in this case, I can assume there that my A is 1 and my B here is 1. So I only have one transformation here, which is a x, which is pi halves to the left. So I automatically know that that is shifting my graph pi halves to the right, but we'll talk about that as we get through it. So let's just go on and go through our, identify our period. Remember, the period is going to be 2 pi. I'll write this one out. I'll write this one out first, but then otherwise I'll just kind of abbreviate this with a p. So our period is 2 pi divided by b. We can see that we don't have a value for a b, so therefore we can say that's going to be 1. So that's just 2 pi over 1, which is just equal to 2 pi. So the first one, I'll break it down slowly, and then we'll kind of move forward. The phase shift is, we can see that's just going to be, that is going to be our c, and remember it's x minus c, so therefore c is going to be, since that's an x minus c, so c is equal to pi halves, so that means we're going to be moving to the right. So I'm going to want to make sure I distinguish where I'm going, so pi halves to the right, or I guess I should write right pi halves. Okay, then we have our vertical shift. So I'll just say vertical shift. Oh, and I didn't talk about, okay. And our vertical shift, we're not moving the graph up or down at all, so therefore that's going to be none. And then there's no reflections, so I'm just going to say not going to write anything down for reflections. Actually, I'm not even going to write vertical shift because there is no vertical shift, so let's not even deal with it. So there's no vertical shift. We're not adding or subtracting any d, so we're not moving up. There's no reflection. There's no negative, so we're not reflecting about the y-axis if it was multiplied on the outside, or the y-axis if it was multiplied by negative on the inside, or the x-axis if it was multiplied by negative on the outside. But now let's go and talk about the range. Now, I didn't ask for the domain because for sine and cosine, the graphs continue indefinitely, so therefore the domain is all real numbers. To understand the range, let's just kind of do a rough sketch of the graph to better understand that. So what I'm going to do is I'm going to first sketch the initial period. So this is the sine graph, so I know this graph kind of looks like this. So there it went from 2 pi. And there's the 1, and there's to negative 1. Okay, so what happened is, so here's that pi. Let's actually put in some points here. There's pi halves. And this point would be, here, I'll zoom in, 3 pi halves. Okay, so what's happening here is the graph is being shifted pi halves to the right. So basically all these points are going to be moved over pi halves to the right. So let's go ahead and let's go ahead. So that'd be 3 pi halves, 4 pi halves. So then this would be 5 pi halves, because 2 pi is 4 pi over 2. So that'd be 5 pi over 2. So the graph would actually just look like this. Same kind of transformations, or same graph, just being shifted over. And there you can see what that graph is. Now, the important thing is to understand, now we can kind of look at the range, or at least have an understanding of how this range has not been affected, right? So, you know, the graph was not stretched vertically or compressed vertically, and it wasn't shifted up or down. So therefore, my domain is going to, or I'm sorry, my range is going to remain the same. So the range is going to be from -1 to 1. And there you go. All right, so now we can see that we are multiplying by 1/3 on the outside. So basically that is going to be vertically compressing the graph. But we don't talk about the vertical compression here. We just basically talk about the amplitude. Did I not mention amplitude? Oh no, I forgot to write an amplitude. We got to remember the amplitude. Remember, the amplitude is half the distance from the max to the min. It's also the absolute value of A. I cannot believe I forgot to write that in there. That is one of the big keys in sine and cosine. So the absolute value of the amplitude, or the amplitude, is just going to be absolute value of A, which in this case is just 1. And you can see the half distance from -1 to 1. You can see that distance is 2. Half of the 2 is 1. All right. So I usually like to do the amplitude first, because typically it's like the easiest to do. So all we're going to do is take our A here, which is 1/3. Now again, you could kind of write this out. Yeah, let's just write amplitude here. I'm just going to abbreviate amplitude, and so that's going to equal absolute value of 1/3, which is just equal to 1/3. Now, I don't really like this with the bx minus c, because we have a b and we have a c, and we want to write it like this. So what I'm going to do is I'm just going to rewrite this equation by factoring out that 2. So I'm going to write this as a 1/3 times sine. If I divide out the 2, then I would have a 2 times x plus pi halves. And again, we say, well, here's the pi halves. Well, again, remember, I'm dividing out of 2. Factoring is like dividing out that 2. And again, if you just want to check your work, like multiply back. 2 times x is 2x. 2 times pi halves is pi, right? So now let's just go, we'll come back to that as we need it. So the next one is going to be the period. Okay, period is going to be, again, 2 pi divided by RB. So I'll just do 2 pi divided by 2, which is equal to pi. And again, the period, you can see that instead of the graph taking 2 pi to repeat itself, now it's going to be scrunched. So it's being horizontally compressed into pi. And let's go ahead and see. The phase shift is going to be how far we're going to be shifting to our right. And you can see here, it's kind of confusing. You might think, oh, it's being shifted pi units to the left. But again, once we have to factor out that b first, and we can see it's being shifted pi halves to the left. So therefore, I'll just do the phase shift, and we'll do left pi halves. Vertical shift, there is no vertical shift being shifted up or down. What I could also see, though, is since the graph is being compressed by 1/3, that means instead of the graph going up to 1 and down to -1, it's only going to go up to 1/3 and down to 1/3. So therefore, the range in this case is going to be from -1/3 to +1/3. Okay, now we know that the initial period starts at 0. So if I'm being shifted to the left pi halves, well, then you can see that this graph is going to start at pi halves. So we can just, or negative pi halves. Right? And then we basically now got to think about, well, now the period is ending at pi. Or sorry, the period only lasts for pi. So what is basically pi plus pi halves? And so therefore we could rewrite that as 2/2. So that's going to be a positive pi halves. And again, if you kind of calculate this distance here, the distance from negative pi halves to pi halves is pi, right? Here's half pi, here's pi halves, here's pi halves. So this graph is going to look very, very scrunched. So we can say, I'm not going to go through the coordinate points here, but let's see, that'd be 1/3. And that would be down to negative 1/3. Okay, and then obviously we could also find the x scale to find like these coordinates where the max and the min is, which is, I'm not sure, yeah. We could also find the max and the min here, which would be at a negative pi over 4 and pi over 4. You can see like where those points would connect in there. And again, just to kind of find the x scale, what you can do is see how these are 4 different points. That's one thing I didn't talk about because we don't really cover it as much in my class anymore, but all you do is just take the period and then divide it by 4, and that way you can help find those points. But hopefully that's going to take a look, and you go, you know, let's just actually look at this. So I don't know why I didn't write this in there. Y equals sine of x. Okay, so here's the sine of x function, and then let's go and take a look at this one. So you can see here how the graph is being shifted over now pi halves, and then it's completing one circle here into pi halves. So you can see like this initial period from here has now been condensed, right, compressed, and then now it's basically being shifted down to this point, which is at negative pi halves, and then it completes its revolution here at pi halves. So just so you can kind of see how that works, and you know, can see that obviously my work is correct. All right, so now let's go ahead and work on, let's go and take a look at another sine one. So this sine has a negative inside, and if we remember from functions, that's going to be a reflection about the y-axis. And you can say that there is a 1 inside of there, or for our a. So our amplitude, that's just going to be absolute value of 1, which is equal to 1. Our period, now this one is going to have a nice little fun. Our period, again, is, remember, 2 pi divided by 2/3, by our b. Now, we don't need to include this negative. We can just factor that out. The period is always going to be a positive distance, so we don't need to worry about it being the negative version, because it doesn't make, we don't care about that if it's positive or negative. Now, this sometimes gets confusing. Remember, we have a number divided by a fraction, so we're going to want to multiply by the reciprocal. This is something we've done quite a bit. That goes to 1. The 2's will divide out, and I'm just going to be left with 3 pi. All right, they don't have any phase shift. We're not adding or subtracting inside of the function, but now we do have a vertical shift, and you can see that the graph is just being shifted up 1 unit. All right, the next thing that we're going to be looking at is identifying the what else we got to do? Amplitude, period, vertical shift. We got to look at the range, right? Yeah, the range. So the range is, if we didn't have that vertical shift, this graph would just go from -1 to up to +1, right? But now the graph is being shifted up 1 unit. So what you can basically see is, let's look at this original graph. It's basically like the amplitude, the same range as this graph, but the graph is being shifted up 1 unit. So now, instead of it starting at 0, it's going to start at 1, it's going to go up to 2, and it's going to only go down as 0. So the range in this case is going to be from 0 to 2. Let's see, no vertical shift. Okay, so let's just go ahead and sketch a nice little graph of this. I'll put this down here. So again, since we're not shifting left or right, oh, and then also just remember we have that reflection. So reflect the y-axis. Make sure you write in those reflections. Okay, so that's important, because if we look at this graph, if we were about to reflect this about the y-axis, it kind of looks a little confusing what's going to happen, all right? And actually, we might have to go into, let's go back into Desmos to kind of take a look at that. So, oh, where did my graph go? Y equals sine of x. Okay, now that's y equals sine of x, and if I was going to do y equals negative sine of x. You can see now the graph being dipped. So instead of me starting at 0 and then going up, I'm now going to be going down and then up to complete my period. So that's just kind of like the visual understanding as far as where we're going with the sine graph, so you can kind of see it. So instead of me starting this initial period and going up, I'm now going to be going down. Okay, so we're going to start at 1. And remember, we go up to 2. Here, and then our period is just going to be at 3 pi. So we're going to end at 3 pi. So now I'm going to be going down, up, and there. And again, guys, if you want to be able to figure this out, basically you take 3 pi and then divide it by 4, and to get those points, which it's not really going to be that much fun. So that's why I just like to kind of have a rough sketch of what's going on. But then you can go and do it. So that would be, you know, pi over 4, 2 pi over 4. Oh, no, sorry, 3 pi over 4. Yeah, that'd be 3 pi over 4, pi, 6 pi over 4, 9 pi over 4, 12 pi over 4, which would be 3 pi. All right, so now let's go ahead and take a look here at y equals -2 sine of x minus 2. A lot of 2's going on here. First thing is amplitude. Now here, finally, our absolute value is going to come into play, because remember, guys, it's the absolute value of -2. So that is just going to be 2. The period is not changed. We can see here we just have an x. I think we had that before, right? Yeah, we didn't. No. So period is just x, so that's just going to be 2 pi. 2 pi divided by 1, I guess, right? The b is 1, so 2 pi divided by 1. We don't have any phase shift. We do have a vertical shift, though, which is going to be down 2 units. I'll just write down 2. Now, this one is important, too, because now we have an amplitude as well as a vertical shift. So we got to think about what's happened to the graph. It's being vertically stretched by a factor of 2, right? So it might be helpful in this case to understand what is kind of going on, how we do that. So let me just kind of do a rough sketch over here. So here's the graph, right? Here's the parent graph. Let's do a rough sketch, okay? If the amplitude is 2, then now the graph is going to look like this. So now it's going to go up to 2, down to 2, and then ends right there. And but now the graph is being shifted down 2 units. So now we're basically going down 2 more units. So now you can see this graph is going up from here, down there. And I'm just doing this just so you can see what the range is. The range is not going to be from -2 to +2. It's not going to be from -1 to 1. It's going to be from -4 to 0. So the range is going to be from -4 to 0. Now, the only other thing we need to consider is the reflection about the negative. And I want to kind of go back to Desmos, because this is important to understand about this odd function here, is when we have an odd function, let's go back to this one. Oh, that was the negative on the inside. Never mind. Crap. Well, what I wanted to show you, and I apologize for that in the last one. There you go. My bad. It doesn't matter where that negative is. If you have a negative on the outside, okay, you can see that these 2 graphs are exactly the same. Here's sine of x with the negative. Here's sine of x with the other negative. So it doesn't matter if you're reflecting about the x or the y-axis. And again, the reason why that's important is because this is a odd function. All right, so the odd function, we just know that if it's reflection about the x or the y, the graph is still going to look the same. Instead of like starting here and going up, we're now going to be going down. So if I'm just going to graph this initial period here, so oops, let's do this up here. Let's say here's -4. Here is -2. And our period is still completing at 2 pi, right? Okay. So we'll still say here's 2 pi. So now, instead of going up, we know the graph is being reflected, right? So let's just put pi there so I can kind of get some bearings. So now the graph is going to go down, cross, up, and there you go. And there you go. That is the initial period here for the sine graph. So now let's go ahead and get into our cosine functions, which is basically the same process that we did with the sine, but now with the cosine, we're just going to be dealing with our a new initial period, right? So instead of starting at 0, we're now going to start at the point 0, 1. You can see that the x scale is still the same, going by pi halves. And then we start at 0 and going to 2 pi, going up to 1, going down to 1. All right, so now let's go ahead and get into the